Hey there, and welcome back to the video series. So we talked about selection sort in the previous video, and it was a bit faster than BubbleSort, even though it is still a quadratic algorithm and it is in the same time complexity class. So in this video we're going to talk about insertion sort, and that is the fastest of the simple sorting algorithm. It is still n raised to the power of 2, and also execution time should be increased by 4. But let's have a look at the visuals. How does it actually perform here, and how does it work? So if we make a new sort, we have an array here. If we start the algorithm, the first thing we can see that it will not go through all the elements in each loop. It will start by including more and more elements, and then comparing them, and then it will place the new element in the correct order in this sorted array here. So it's going to insert it at the correct place in the array. And this means that if we speed up the process, that it's going to include more and more elements of the unsorted array into the sorted one, and then it's going to place the current item at the correct place. And we can already see here that if we take a look at the comparisons, BubbleSort and SelectionSort was around 120 comparisons, so we're around 75 here. So that's a bit fewer there, and it is the fastest one. So if we take a look at also in this overall picture, insertion sort is down here. We can see that overall it finishes first if we compare all the simple sorting algorithms. If we have this random, it is actually quite fast if we have a random array here. So how do we implement this algorithm in our framework? So let's see, we have the algorithm here, and we can see we still have the two loops. We have the outer for loop that goes through all the elements in the array, but then we have this while loop that will move the whole to the correct position, move this item we're looking at to the correct position in the sorted array. And this will not go through all the items in the array. Okay, so the runtime should be a little bit faster, as we can see, and we will try to benchmark this. So if we take the code and do the same process as we did for selection sort. So let's just start by making a new class again called InsertionSort. All right, so the last of the simple algorithms. Extends generic algorithm. All right. Again, let's implement the do work method here. And again, IntelliJ is angry with me because I don't have the constructor, so we will implement a constructor. And let's just zoom a little bit here. Let's take away the default parameters here. Let's write insertion sort. Fastest simple sorting algorithm, big O of n raised to the power of 2. And again, we're dealing with sorting algorithm type. All right. So now we just need to implement this one here and test it out. We can see the code here of the algorithm, and let's just put it into our do work method there, and we can see we need to do the same trick there. And let's make an array here, and let's call this B again, and let's typecast this from super get data that contains the test data that we can work on. All right, so that is the algorithm here. Let's connect it to our loader. Let's make a new line there that will insertion sort. So we got our last algorithm, the symbol sorting algorithm, and let's fire it up to see how it works. So now we can see we have insertion sort, fastest symbol sorting algorithm, still same time complexity. And if we take the same input, let's just skip the first because they might be unprecisely measured. Let's take this amount here, 8, 16, 32, 64, doubling up here, and start the search here. So we can see that 128,000 is 5 seconds. Recall that if I think it was BubbleSort, that was taking around 32 seconds for this. So we can see BubbleSort only can do 32,000 in a bit more than 4 seconds. So clearly it is slower. Let's just see here. Okay, I'll just pause the video until BubbleSort has finished. Alright, so we're back here and we can see that BubbleSort completed sorting 128,000 elements in whopping 60 seconds. It matches okay the time complexity that it should be multiplied by 4. We can see 4 seconds, 16 seconds, up to 60. If we take insertion sort just as a comparison here, we can see that it is much faster. Much faster. So we might even add an extra one here, an extra input size, so we can test out 265. Okay, so we can see here that insertion sort can do double size of what BubbleSort can do in 60 seconds. Insertion sort can do this in 17. We can see if we hover over here, 17,000 milliseconds. So it is clearly a lot faster, and selection sort is kind of in the middle there between. So insertion sort, if you're going to use a symbol sorting algorithm, you should go with insertion sort because it is clearly the fastest one. But there will be better options out there that will use another programming technique that is called recursion, that will allow you to kind of divide and conquer, separate the task, divide it up in 2 steps, and then call itself. But we will also talk about this later on. Okay, so this kind of concludes the first video series here about the simple sorting algorithms that basically works using 2 loops that will sort in varying ways, will sort the arrays. Alright, so I hope you have made it work and have fun with this. Bye bye.